So we did one example on linear power and with the dog sled team and measuring how much power a dog can generate as it's pulling a sled across the snow. Now let's look at rotational power. So this is what we really need to know for our engine, what we want to get after. How much horsepower can an engine develop, how much torque and speed, and how is it related, and so forth. So here's the example that we're going to do. So a small gas engine was tested on a dynamometer. So this would be typical of what you would have in a lawnmower, a snowblower, or something like that, a small device with a small gasoline engine on it. And on the dynamometer, it said it generated 174 inch-pounds of torque. So there's our units, and we're working in the English system now. So we got torque and speed in inch-pounds, or torque in inch-pounds. And then the speed is 2,900 RPM. And an RPM is a revolution per minute. So that's what the speed, how many times that shaft revolves, rotates per minute. So 174 inch-pounds of torque at 2,900 RPM. So how much power did it produce? Okay, so let's do this. All right, we're going to take the shortcut, and I'm going to show you how we're going to get burnt by taking the shortcut. So I went to Google and said, what is the equation for power? How do I calculate power? Well, Google spits back this nice equation up here. You know, we saw this power equals torque times speed. We learned that that was the fundamental relationship that we're working with. But Google tells me, oh, I've got power is torque times speed divided by 5252. So let's believe Google and see what happens. So let's just plug it in. Let's just say that power is equal to torque times speed divided by 5252. Plug in our numbers. What is our torque? Our torque is 174, so 174 times what is our speed? Our speed is 2,900, and I divide that by 5252, and I plug those numbers into my calculator. I say 174 times 2,900 divided by 5252, and that tells me that this is 96. That's what my calculator tells me. 96 what? Well, okay, I'm in the English system, English units, so that must be 96 horsepower, right? So if I'm calculating that, 96 horsepower. Now, if you're thinking a little bit, and when we do these math problems, stop and look at your numbers and say, does this make sense? So this is a small gas engine like you would have on a lawnmower or or something like that. A small engine. This says 96 horsepower. 96 horsepower is a really big tractor. That's a good sized tractor. So you're talking 12,000 pounds. Does your lawnmower have 96 horsepower? Oh, what's going on? Something isn't right here. So this is wrong. And I'm even going to change my pen to red and mark this one out because this is incorrect. Google led you astray. How did Google lead you astray? What did Google do to us? Here's the deal. Let's do this the right way. We're going to start with our fundamental relationship and say that power is equal to torque times speed, and we're going to watch our units. Now, what do we want? Before we start plugging stuff in, let's ask ourselves, what units do we want to have? Well, ultimately, I'd like to have a horsepower. So let's put that horsepower over to the left. Now, we said that horsepower is not really a fundamental unit. To get down to the fundamental units, I have to look at foot-pounds per second. And that's where I need a conversion factor. And I'll put this on the upper right-hand side of the slide to say that 1 horsepower is equal to 550 foot-pounds per second. This is a conversion factor. That's a definition. That's something that you can look up anywhere, and that's always going to be correct. So 1 horsepower is the same thing as 550 foot-pounds per second. So going down to our equation, ultimately what I want is a foot-pound per second. Those are the fundamental units that I'm trying to go after. So as I build my equation and then look at the units as I'm going across, that's ultimately what I want to end up with is foot-pounds per second, and then I can plug this conversion onto it to get the horsepower that's going to make sense to me. Okay, so let's do it. Let's put the numbers in. So what is power is torque times speed? What is my torque? We said that the torque was 174 inch-pounds. So there's inch-pounds. Now, there's nothing on the bottom of that, no units that go on the bottom. So to keep the fraction, what I'm going to do is put that over 1. I'm going to keep the fraction there. So if there's nothing underneath there, put it over 1. So I have the fraction. So there's 174 inch-pounds. I'm going to multiply that by my speed, torque times speed. What is my speed? Speed up there says 2,900. And this is RPM, and we're going to break out those units into their fundamental pieces, a revolution per minute. So there we go. What do I have? What units do I have there? Well, let's see. I've got a pound up here. Hey, that's what I want. I want a pound over there, so I'm good on the pounds. I'm not good on the minutes, and I got this revolution, and I've got inches up in here. Okay, so I got to do some fixing on this stuff. So let's start with the inches. That's going to be an easy one to take care of. So inches, I want foot. I want feet, and I've got inches. Well, how many inches in a foot? 12 inches in a foot, right? So how do we do that? So I want to get rid of the inches and have foot on the top. I want the foot left over on the top. So I'm going to put 1 foot on the top because that's what I want. And 1 foot is the same as, is equivalent to 12 inches. And now I've got inches in the denominator, inches in the numerator. They're going to cancel off. So inches is gone, inches is gone. And now I'm left with feet in the top. So what do I got? I've got my pounds. That's what I want. So the pounds is a good thing there. I'll circle that. I've got foot now. That's a good thing. I want that. I've got minutes. I don't want minutes. I want seconds. So how do I get rid of minutes to give me seconds? Oh, okay. So I can do the same thing. How many seconds in a minute? 60 seconds in a minute. So 1 minute in the top, because that's what I want to get rid of. The minutes are in the bottom already, is the same as 60 seconds. So I can cancel the minutes off and give me seconds. So now what do I got? I've got my pounds in the top. I got my foot in the top. I've got seconds in the bottom. That's what I want. Sweet. But I've got one more thing that I have to deal with. And here's where the math is going to get kind of squirrely on us. And I'm not going to go into all this theory. We could prove this and all that, but you're going to have to trust me on this one a little bit, because when we talk about revolutions, that's one complete revolution of a shaft. The way we get rid of a revolution unit when we don't want it is we talk about radians. And you might remember from some high school math classes or something like that, we talked about degrees and radians and gradients maybe and all that kind of stuff. But here's the magic. Just consider this magic, that 1 revolution is the same as 2 pi radians, okay? And I'll write radians here, but I'm going to put that in a bracket because radians is, we consider that to be unitless. We can ignore it, so it doesn't matter. So when we have radians, it's nothing. We just ignore it, it makes it go away. So here's the cool thing. To just get rid of radians, we just say that we get rid of revolution. We put the revolution in the denominator now because I have it in the numerator. I want to get rid of it. So I'm going to put the 1 revolution in the denominator. That'll make it cancel. Now in the numerator above that, what's equivalent to 1 revolution is 2 pi. And again, I'll stick the radians on a bracket, but we ignore it. We consider that to be unitless. So most of the time, I'll not even write that in there. I won't even put that radians in there. So that'll just be 2 pi per revolution. What does that do for me now? Revolutions cancel. And sweet, what am I left with? I'm left with the pounds up here. I'm left with foot. I'm left with seconds. Everything else is gone. We'll ignore the radians. Okay, so there's my foot pounds per seconds. Now let me go ahead and apply this conversion up here to horsepower so that I end up with the horsepower there. So multiply one more thing. I'm going to say 1 horsepower is equivalent to, so that's the way I say that, 1 horsepower is equivalent to, so that becomes the fraction. I'm going to put the 550 in the denominator. That's foot-pounds goes in the denominator per second. Now, instead of doing foot-pounds and then another one underneath that, on the foot-pound, the per second actually goes back up in the numerator. So foot-pounds per second, so it gets popped up in the numerator. So it's like the whole thing got flipped upside down. And now look what I can do. What do I have in the top? I've got my seconds up here, seconds down here. They're going to cancel. Foot and the pound are going to cancel with the foot and the pounds over there. So I'll go ahead and do that. Seconds is gone. Foot is gone. The pounds are gone. What am I left with? The only thing I'm left with now is the horsepower. That's what I wanted. And now it becomes a calculator problem. So what I do, multiply again, everything on the top. So if it's in the numerator, I multiply it. So I'm going to take, in my calculator, 174 times 2900 times 2 times pi. And that's all the numbers other than 1 on the top. And then I say divided by, go across the bottom here, divided by 12, divided by 60, divided by 550. And when I do that, that gives me an answer of 8 horsepower. Huh. A little bit different than the 96 that I got before. What happened there? Oh, it's the units. It's the units. What was going on? Oh, I had to do all this conversion because I didn't pay attention to Google. All right, 8 horsepower is right. That's about the right size. A small engine like that is going to come out to be 8 horsepower. 96 is not correct. What did I do wrong? Here's the lesson. And you can get burnt with this if you're not careful. So always do it this way. You'll never screw up if you do it this way. Google, if you read carefully about this equation only works if your torque is in foot-pounds and your speed is in RPM. Where was my torque? Was in inch-pounds. So I'm off by a factor of 12, and that's the way it works out. So if I wanted to use this equation, I would have to convert that torque before I even started, and then it's more hassle and more headache. So I'll do that for you, but it's a whole lot better and foolproof to do it this way. So what would I have to do? I would have to say that my torque was 174 inch-pounds, and that's over 1. That's a fraction. I would have to say, if I want that in foot-pounds, I got to get rid of the inches, so I have to say that 1 foot is the same as 12 inches. And if I multiply 174 divided by 12, that tells me that that is 14.5 foot-pounds. Right there. So that's my torque. Now I could plug that into this equation where I can say the power equals torque times speed divided by 52. The torque that I plug in is not the 174 like I had, it's that 14.5. So if I take 14.5 times my speed of 2900, divide that by 52, then that is going to give me 8 horsepower. That would be correct. That would be correct number. But I had to know what units go into that equation to be able to do that correctly. Again, I can try to keep track of that and remember that, or I can remember this fundamental relationship that we have up here, plug in whatever units conversions that I need, and I'm good to go. So you never make mistakes that way. That's the key thing. That's what is important to us. So understand that. Now, if we want to go a little bit deeper into the math and everything, this whole part of this equation, all of this units conversion stuff, all of that units conversion stuff, that's what gets chunked into a number down here. These would not come out to be 52 because I started with inch pounds. If I put in foot pounds there, then these numbers, if I just multiplied and divided these together, I would end up with a 52. So this is all just a units conversion. That's what the 52 in that equation is supposed to be doing for us. It's converting units But I've got to have the right units to start with to be able to end up with the right units. So do it this way and you'll always be correct, okay?